Welcome to Maths and Science by IITian. In my lecture in physics for NEET and JEE, we are continuing with the rotational motion and rigid body motion, and there is a physics killer concept in this. For example, a rigid body is there, from there some part of the rigid body is removed. Then what happens to this moment of inertia? It differs. It is not the moment of inertia of the removed body is removed directly from the moment of inertia of the original body. It should not be done, because the distance from the rotational axis of the removed body differs from the original body. Hence, this is a killer concept, and let us try to solve this concept very clearly. Let us try to understand. This type of question is given in JEE Mains 2025. It is not the direct question, but question is given like this only with some different dimensions in 2025 JEE Mains. Please refer to that and solve that problem in the same steps as I explain you in this lecture. Now, let us say the original body is of this color, and white color portion is this portion is removed, cut from this original body. The original body has a radius of r. The cut body has a radius of r by 4 is cut. Now what happens to the moment of inertia of the cut of the body from which r by 4 disc is cut or r by 4 disc is removed? This radius is r by 4, that disc is removed from the original body of disc of radius r. Then what happens? What happens to the effective moment of inertia? That's what is our question. People make a mistake here. They directly take out half into mr square for the total original body, and they deduct half into mr by 4 whole square, and they get an answer of 255 by 512 mr square. That's a wrong answer. 255 by 512 mr square, that is a wrong answer. We should get something like this: 237 by 512 mr square. How? That is the question here. Now, let us proceed further to solve it. It is a very important question. Same type of question is asked in JEE Mains 2025. Same type of question, not same question. Now, what is the original body? Let us draw here. This is the original body. This is the origin. Now, original body moment of inertia is half mr square, which I have explained in the shorts and also in the previous classes. For a circle of radius r with axis of rotation as center, then I is equal to half mr square. This you are already aware. Now, a portion of r by 4 is removed, then cut body I, this is original body, cut body I with respect to its own center. Please understand this. Cut body, the radius is r by 4 with its own center, with its own center of mass. Cut body is half m r by 4 whole square. But we are not calculating the, when you calculate the effective moment of inertia, we have to calculate with respect to O, the distance. We have to use the parallel axis theorem for the cut body. I original minus I of cut body with respect to its own center of mass plus, what is the parallel axis theorem says? M d square, that is distance of the center of mass of the cut body with the original body center of mass. That distance. This is the distance. Please understand the meaning of D, where M is equal to mass of the body, mass of the cut body if capital M is equal to mass of the original body M by M is equal to because density is same. Mass ratio will be, because we are calculating for I is equal to mr square, we have to do it like this, r square by r by 4 whole square, that is equal to 16. That implies small m is equal to capital M by 16. Because when we have cut from the circular disc a portion, it is not a sphere, it is a circular disc. It is a circular disc. It will be having mass is equal to, in circular disc, already in wire we have seen, in circular disc area into areal density. There we have taken the linear density, here we are taking the areal density in a circular disc. If it is a sphere, then we will be taking the volumetric density. Now this is mass. That means pi r square into areal density. Areal density will not change because we are not changing the properties of the material. Properties of the material are kept as same. Then the masses will be in the ratio of area. For circular disc, please remember this also, it's a concept. For circular disc, mass ratios is equal to area ratios. Very important concept. In case of, if the same material is there, in case of linear dimensions only, linear thin wires with only linear dimensions only, then mass ratios are is equal to length ratios, how much length it is there. This is also important. If it is it's a two-dimensional body, sir, it is a one-dimensional body. If there is a three-dimensional body, if there is a three-dimensional body like sphere or anything, cone, sphere, having three dimensions, then like this, three dimensions, then your sphere with three dimensions, x, y and z, x, y and z. These things you should be able to understand. Then in three dimension, mass ratios will be, because densities are we are keeping same, volume ratios. You should understand this as per the given question. Here in this question, we are dealing with the circular disc, hence area ratios are mass ratios. Then m by m is equal to 1 by 16. That implies small m is equal to capital M by 16. You should agree this. Now, we have come to this. And what is the distance between the center of the removed mass and original center of the original mass? We have to find. That is the crucial part here. That's where we apply our parallel axis theorem and find out. This is the cut body and this distance is r by 4. This distance is r. Then from this center to this center, what is d? This is d. From the center of the remote disc to the original body center is the distance, center of gravity distance. That's what is d in our parallel axis theorem, which I have explained in detail in my previous videos. Therefore, I effective is equal to I of the original minus I of removed plus small m into d square. Here I effective is equal to I original is half m r square minus I of the removed body. What is I of the removed body? Small m into r by 4 whole square, because radius of the removed body is r by 4 plus m into distance. D is That is the crux of the problem. dE is equal to original center of mass minus center of mass of removed body, because that is removed portion, we can say. That is equal to R minus R by 4. Center of mass is at R by 4 for the removed body. That is 3R by 4. We will replace these values here and we got that M is equal to M by 16. That implies I effective is equal to half MR square minus M by 16 into R square by, it is half, 1 by 2 into M by 16 into R square by 16 plus M is M by 16, capital M by 16, D is 3R by 4 whole square. This becomes I effective is equal to half MR square minus MR square by 512. 16 into 16 is 256 into 2, that is 512, minus 9 MR square by 16 into 16 is 256. This is plus, this plus, because already minus we have put in the bracket itself, before the bracket. This is what it is. Then this becomes half MR square minus 512, we will take it as in the denominator. Then this will become MR square plus 2 into 9 is 18 MR square. This is equal to MR square, we will take it out, 1 by 2 minus 19 by 512. That is equal to MR square into 256 minus 19 by 512. That implies effective moment of inertia is equal to 237. 256 minus 19 is 237 by 512 MR square. This is the answer for this problem. Here you please remember one thing, you should not take the moment of inertia of each body and directly subtract. You have to apply the parallel axis theorem, then only you will get the effective body moment of inertia. That means if a circle is there, in the circle one-fourth portion, R by 4 portion is removed, if it is R, and if it is R by 4 portion is removed, then this is the answer for effective moment of inertia. I took a little time because I want to explain the theory when a original body is cut. This happens in almost all the engineering applications. Manufacturing industry will make a die, will make a solid, and will cut some portion of it for meeting the requirements of our design. For example, semicircle will cut elliptical shape from the original body. Then moment of inertia changes. Once moment of inertia changes, what happens? This stresses and strains in the body change, and the stability of the body change. These are all engineering considerations for which moment of inertia of the rigid bodies is one of the most important topics where you have to master it. And we have done till now on rotational motion. We understood what is the rotational motion, what is angular velocity, what is moment of inertia, and what is the original body moment of inertia, how to apply the parallel axis theorem, and how to get the effective moment of inertia of the cut body, of the body from which some portion of the body is cut. This is all about the rotational motion, and with some more good topic, I will come back in the next lecture. If there is a value addition to your knowledge because of this lecture, please subscribe to my channel Maths and Science by IITian, and kindly share and subscribe. Thank you for listening to me. Thank you for viewing my lecture. Best of luck to everybody.